Hey, welcome to our third e-learning lesson. This time I have decided to have the camera on so you can also enjoy my face while I talk on stuff. We are going to go over an article about MIG welding gun and consumables and some of the mistakes that people make with them that just make stuff not work as well or wear out too quick. So we're going to go over that. I am going to post the article by itself if you would rather just read it on your own rather than just listening and watching me read it. Otherwise, you can do that, listen to me read it and read it along with me. And then there will be some questions to go along with this that I'll put up on Classroom as well. So let's go ahead and get started. So GMAW Gun and Consumables, 7 common mistakes and how to avoid them. So, all right, gas metal arc welding, or GMAW, I'll call it GMAW, offers numerous productivity benefits without sacrificing weld quality. However, many factors can interfere with successful GMAW performance. By taking steps to avoid the following common mistakes related to your GMAW gun and consumables, you can improve performance and save money through reduced consumable waste. Number 1, cutting the liner too long or short. Cutting the liner the wrong length, usually too short, is a common problem in GMAW. When the liner is the wrong length, it can become deformed by the force of the drive rolls pushing the wire forward, causing an oscillation in arc length. Like a big spring, when the liner deforms, it takes up whatever free space there is in the conduit inside the gun. This can result in vibration or chatter in the gun. Ensuring the liner is the proper length can help prevent this problem. So basically what that's saying is if the liner isn't the correct length and it starts to get bound up or whatever, it's going to make the wire kind of be jagged as it's going through and kind of inconsistent in its feeding. So use a liner gauge as a guide. When installing a gun liner, make sure the gun is as straight as possible and that there is little to no twist in the cable. Laying the welding cable flat and straight during welding will ensure the smoothest feeding. Twisting or coiling the cable can change the effective length of the liner and can cause the cable to take on a permanent set. So that's why I say when you're welding to leave the cable in as big of a loop as you can and as straight of a line as you can. That way will help it feed better. So number 2, welding with overheated consumables. Overheated consumables, including the liner, contact tip, and nozzle, can cause a lot of problems. Be sure to use the proper wire stick out, pay attention to the gun's duty cycle, and employ the right contact tip to work distance to prevent consumables from overheating. Any steps that keep these items cooler will help limit the amount of vibration in the gun and reduce burnback. While wire stick out that is too long is not desirable, keep in mind that stick out that is too short places the nozzle and contact tip too close to the weld pool, causing them to overheat. This hurts productivity by causing burnbacks, and wire sticks and can shorten consumable life significantly. Number 3, using poor grounding. The life of contact tips and other front-end consumables can be shortened if a solid ground isn't in place during GMAW. Without a solid ground, the arc can become erratic and ultimately cause excessive heat buildup in the front of the gun. Anything that creates more heat also will create more resistance and more wear, damaging the contact tip and the other front-end consumables and possibly affecting weld quality. Whenever you change consumables, check that the gas holes in the nozzle are clean and that the seat that holds the contact tip isn't filled with spatter or debris. A clogged contact tip or nozzle can cause overheating in the gun and handle. To ensure a good ground, place the ground cable as close as possible to the workpiece. If it's feasible, hook the ground cable on the weldment, so the piece that you're welding. If you can't do that, hook it to a bench, but remember the closer it is to the arc, the better. Number 4, setting voltage, wire feed speed incorrectly. Setting voltage and wire feed speed incorrectly can produce an erratic arc. If you set the voltage too high, it can create too much heat in the handle of the gun, which in turn can eventually wreak havoc on the contact tip. When the wire feed speed is too fast, it can cause the wire to pile up instead of melting properly into the weld pool. This can also cause burnback or bird nesting. Wire feed speed that is too slow doesn't feed the weld pool, so there is not proper penetration for a quality weld. Always follow the manufacturer's recommendations for the proper voltage and wire feed speed for the filler metal and thickness of the base metal material you're welding. Number 5, managing cables poorly. Poor power cable management can lead to performance problems and cable damage. To help prevent damage or other issues, don't pull the welding machine around using the cable. When the gun is hot, everything is more pliable. Yanking or pulling on the cable can stretch it or the liner and even cause the conduit to pull away from the gas pin, which can result in shielding gas problems. Make sure to let the gun cool while it's resting in a flat position rather than draping or hanging the cable over a piece of plate or some other object. When a hot gun is draped or hung over something, the conduit can bend. When the gun and consumables cool, they can be misshaped, leading to marginal shielding gas coverage. Also, be sure to store the gun and cable properly when they aren't being used. Doing so will help prevent damage that can occur if a cable is run over by a forklift or other heavy equipment. So, we aren't going to have a lot of forklifts or heavy equipment running around in our shop, but it's still a good tip to keep in mind in case you are in an environment where that is a possibility. Number 6, using the wrong gun. If you spend all day welding at 300 amps while using a 200 amp gun with a 30 or 40% duty cycle, you'll find out that this gun will not be up to the task. One thing that I should probably tell you guys, if you don't know or don't remember, I think we've covered it briefly this year, but duty cycle is the amount of time that a welder can run at its max capability in a 10-minute period. So for a 30% duty cycle, that would mean that in a 10-minute period, that welder could run at max power for 3 out of 10 minutes. 40% duty cycle would mean it can run at max power for 4 out of 10 minutes. So that's what duty cycle means. So exceeding the gun's duty cycle leads to overheating, and doing this frequently will shorten the life of the gun. Make sure to choose the right gun for the application. Be mindful of the requirements of the job and select a gun with enough duty cycle and amperage capacity. Also, take breaks to let the gun and consumables cool, which will further prevent overheating. Changing shielding gas is another way you can help reduce the heat produced during welding. If you're using an argon shielding gas, the higher the percentage of argon, the less cooling the shielding gas provides. However, keep in mind that many applications use argon shielding gas because it provides a cleaner process with much less spatter for reduced cleanup. So, while reducing the argon can help the process run cooler, there are other trade-offs that can impact productivity. Number 7, using the incorrect drive roll setting. So, using the wrong type of drive roll or setting drive roll tension incorrectly can cause erratic or poor wire feeding in GMAW. Consider the size and type of wire and match it to the correct drive roll. Flux cord wire is soft because of the tubular design and flux inside, so it requires a knurled drive roll, which has teeth that can grab the wire and help push it through. So flux cord wire, if you don't know, is it's very similar to our regular MIG wire, but what we have been using is called solid wire, because all it is just solid metal. Flux cord has actually in the center of the wire, in the core of the wire, a flux like what you would find on your stick electrodes. So it's got that inside so that you could weld in an environment where maybe you don't have a gas tank set up. You could use this flux core, and the flux in the core of the wire would protect the weld. You can also run flux core with gas, as they call dual shield flux core. But anyway, as this says, it's a softer wire, so it needs those drive rolls with teeth on them to help feed it through. So it says instead use U-groove or V-groove drive rolls with solid wire. Setting the drive roll tension properly is another important step. Without the correct tension, erratic feeding can cause burnback or other problems. To set the drive roll tension correctly, start by releasing the drive rolls. Then increase the tension while feeding the wire into your gloved hand until the tension is 1/2 turn past wire slippage. Always keep the gun as straight as possible to avoid kinking in the cable that could lead to poor wire feeding. So it's basically just saying set the drive roll tension just tight enough so it'll feed it consistently, but you don't want to over tighten it. Remember routine maintenance. While avoiding these mistakes can help you achieve the best results in GMAW, it is equally important to properly maintain your gun and consumables, including the contact tip, nozzle, and liner. Whenever you change consumables, check that the gas holes in the nozzle are clean and that the seat that holds the contact tip isn't filled with spatter or debris. A clogged contact tip or nozzle can cause overheating in the gun and handle. Also, check frequently that all connections are tight and as concentric as possible. Keeping the gun and cable as straight as possible during welding and laying them flat to cool makes for an effective and efficient GMAW gun. Following these tips will help you minimize downtime, improve productivity and quality, and save money in your GMAW operation.